All right, next we're going to concentrate on some two-step problems. Two-step problems means you're going to need two pictures and two number sentences, okay, to arrive at your answer. And this problem has Suki, and she has some money. So Suki has 44 cents. She spends 25 cents on a pencil. How much money does she have left? Well, that's step one. And then step two, they have it split right out for you there. It says she finds 33 cents more. How much money does she have now? Okay, so let's start with, she has 44 cents and she spends 25 cents. So again, this sounds to me like a part whole. She has 44 cents. She spends 25 cents on a pencil, and we have to figure out how much she has left. And remember, a good way to represent that is with a number bond. So let's go ahead and draw our number bond. Part whole. And Mrs. Reed is kind of having a hard time getting back in the swing of the school year. So we should also underline our knowns. Suki has 44 cents and she spends 25 cents on a pencil. How much does she have left? All right, so we're going to take this 44 cents that she has, which is her total. And in here, we're going to put what she spends. So I'll put it spends underneath this part. Remember, I want you drawing these pictures as well. And you can pause the video whenever you need to catch up. And if she spends 25 cents, then the other part must represent what she has left. So this is kind of like the one we did earlier. We have a whole or a total 44 cents, and we have one part, and we have to figure out what she has left. That's our unknown. Well, in order to do that, we subtract, because we take our whole and we subtract our one part to find our other part. So let's go ahead and write our number sentence. Remember, we like to start with NS for number sentence. And we're going to take our 44 cents and subtract our 25 cents and get what we have left. Again, really hard to do that math just in number sentence form. So you probably also want to write an algorithm. Remember, an algorithm is when we stack our numbers on top of each other based on place values. So 44 minus 25. Okay, always start with the ones. And I say to myself, can I take 5 ones from 4 ones? And I know I can't, because 5 is the bigger number. So the only way to get more ones is to come over to my tens, unbundle a 10, which would leave me with 3 tens. But it gives me 10 more ones. Now instead of 4 ones, I have 14 ones. I can take my 14 ones and subtract 5. Let you do that math for a minute. Okay, hopefully you got 14 minus 5 is 9. And then we come over here and we subtract our tens. 3 tens minus 2 tens is 1 10. Okay, remember, you can always draw. If you're struggling with how to do that algorithm, the unbundling process, you can always draw your place value chart. You could draw 44 by making 4 tens and 4 ones. These are just place value discs. And then if I want to subtract 25, I can't take 5 ones from these 4 ones, so I unbundle a 10, cross one off, draw my arrow. That gives me 10 ones, and that's where you get your 14 from in your algorithm. Okay, and then that leaves you with the 3 tens that you see up here in your algorithm. And if we take 5 away, I always like to start with my partial rows. So there's 4, and I subtract 1 more, and that leaves me with 5, 9. And then over here I have 3 tens, and I subtract 2 more, and it leaves me with 1 10. So again, that just supports what you're doing in your algorithm. So if that's hard for you to remember, I suggest drawing the place value chart. Okay, and last but not least, then we need our target sentence here. So how much money does she have left? TS, she has 19 cents left. I can even go back and put that 19 in the number bond if you want to make your number bond complete. Now this is a two-step problem because then what happens, she finds 33 more cents. How much money does she have now? This is another part whole because we have what she had left, which is 19. And I'm just going to put an L here for what she has left. And then over here is what she finds. She finds 33 more cents. And so again, part whole, and our unknown is the total, what she has now. That's our unknown. I'm going to give you a second to see if you know how to get the total when you have two parts. Oh, NS for number sentence. Okay, very good. If you have two parts, you're going to take 19, which is the one part, and add to it the second part, which was the 33, and that will give you your total. Again, you can do your algorithm, 19 plus 33. If you're good with math, you can also do mental math. You can say 19 is really close to 20, so 20 plus 33 would be 53, and then take off that 1 because you're not really adding 20, you're adding 19. So, or you can do the algorithm if you're more comfortable with that. 19 plus 33 ends up being 52. So 19 plus 33 is 52. And then we just have to write our TS down here. How much money does she have now? TS. Oops. Sorry about that. $0.52 now. Okay, so hopefully walking you through these, this first two-step problem, or reminded you what you do when you have a two-step problem. It's nice when they break it down into A and B so you can see automatically that it's two steps. But let's go on to our last problem for today in our concept development. There's another two-step problem, and you can read it with me if you want. Farmer Ben picks 87 apples. 26 apples are green, 20 are yellow, and the rest are red. How many apples are red? All right, now for this one, I know he has a bunch of apples. He has 87, and he's got some that are green, some that are yellow, and some that are red. So this is part whole, but it's a little bit different because it has three parts to it. So we're going to draw our number bond with three parts. Again, we should go back and underline our knowns. He picks 87 apples. 26 are green, 20 are yellow, and the rest are red. So if I'm labeling my number bond, let's go ahead and put a G here. The first circle can represent the green, the second circle can represent the yellow, and the last circle are there for red. Now, all three of these make up his total apples. And that is one of our knowns. That's 87. So I'll put 87 in here. And I'm going to give you a minute to go back and put your other knowns in this number bond. Okay, so 26 are green. That circle represents the green. 20 are yellow. This circle represents the yellow, and the last circle represents the red, and I don't know what that is, so I'm going to put a question mark there. Now, they say this is a two-step problem, but they didn't ask me two questions. So I have to figure out, why is it a two-step problem? Well, in order to get the red, I have to figure out how many he already has, the green and the yellow. So I'm going to show you what we're going to do. And I don't know if this is what your teacher did yesterday, but I'm going to make this 3-part number bond into a 2-part number bond. So I'm going to draw a big circle here around the green and the yellow. And that circle kind of means I'm bringing those numbers together. So what do I want to do with those numbers if I'm bringing them together? I want to add them. So my first number sentence will be to add the red apples or the green apples and the yellow apples. So I'm going to take 26, and to that I'm going to add 20. And I bet you can add those two numbers in your head. There's no regrouping there. 26 and 20 is 46. So now I'm going to go back up here, and what I like to do is I like to put 46 in here. So when I combine the green and yellow apples all together, I have 46. All right. Now what I have is really just a 2-part number bond where one big part is 46 and I'm missing the other smaller part, which is the red. So how can I get that number sentence? Well, you know, when you got the total and you got one part, you subtract to find the other part. So my next number sentence will be taking my total and subtracting that one big part that represents the yellow and the green. Okay, now, again, I do not have to unbundle here, but if you're more comfortable, please go ahead and draw your algorithm to do that math. So I'll give you a minute to do that. Remember to line your numbers up based on place value. Okay, because there was no unbundling or regrouping here, this one was pretty easy. Our total is 41. All right, now remember, 2-step problems normally involve 2 number sentences. So you can see our 2 number sentences we used here. The first one added the green and the yellow apples together. The second one took the total and subtracted the green and yellow to get the red. All right, last but not least, we need our target sentence. So our target sentence is, how many apples are red? We're going to say 41 apples are red. Okay, so that's what we would have done in class today. I would have walked students through the concept of solving 1- and 2-step word problems using the read, draw, write process. Okay, and I hope you were able to do that with me. Remember, you can always pause the video to try and catch up if I'm going too fast for you. All right.